Alright, so to find question number 3, find the points on the curve, this one, where the gradient is 3. So they want us to find the points on the curve when the gradient is 3. So what do? You first of all find the derivative, dy over dx. So we can do that. There's a 1, so 3 times 1 will give us 3. Then x, that power reduces by 1, which is a 2. Minus 2 times 3, that's a 6. The power reduces by 1, which is a 1. But of course, you ignore that. I told you that when you have got a number and a letter, you just remain with a letter. For a constant, it is a 0. So therefore, our dy over dx there will be 3x squared minus 6x minus 6. That's the derivative. Now remember, they told us that if the gradient, so they told us that if the gradient is 3, meaning that dy over dx is equal to 3. So I'll equate this to 3. So we can say that 3x squared minus 6x minus 6 is equal to 3. So this one will come this side, it will be 3x squared. Remember, like terms, minus 6x minus 6 to become minus 3 is equal to 0. Then it will be 3x squared minus 6 minus 9 is equal to 0. These same signs you add to give us a negative 9. I can still see there's a number that can go there, so I can divide 3 throughout so that I reduce the expression. I'll remain with x squared there. 3 into 6 is a 2x. 3 into 9 is a 3 is equal to 0. Then at this point, you can now solve this trinomial. If you want product sum factor, or you can use the quadratic formula. The product is 1 in front of x squared times negative 3, which is negative 3. And the sum is the coefficient of just x, which is negative 2. So what are those numbers when you multiply? They'll give you negative 3. And when you add, they'll give you, in this case, right? They'll give you a negative. Oh, sorry, here it was a positive. There it was a positive, so they are positive, 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 such that this one will be a 2 there. Thank you so much. So that should have been the correct, value that we're supposed to have. So basically, the two factors, therefore, to give me, when I multiply, to give me negative 3, when I add, to give me a 3, we can simply talk about negative 1 and a 3. That's what we mean. So therefore, when you factorize that, it will give you x minus 1 and x plus 3 is equal to 0. So you can equate each bracket to 0. Oh, I've factorized already. Yeah, so it is going to be x minus 1, equate it bracket to 0 is equal to 0, or x plus 3 is equal to 0. So it will be x is equal to, when this crosses the equal sign, it will become 1, or x is equal to, when this 3 goes the other side, it will become negative 3. So now what you do when you find the value of x and x there, you can now substitute these values into the original expression so that you know the values of y. For example, I can simply say, let me just clean up this section since we know. I can simply say that, when x is equal to 1, so when x is equal to 1, what would be y? So we replace it into this equation. So it will be y is equal to, remember, it will be 1 raised to the power 3 plus 3, 1 raised to the power 2 minus 6 times 1 minus 10. So that will give me 1. That will still give me a 3 there. That will give me minus 6 minus 10. So y will be equal to, well, if you put that on the calculator, you are going to find that you're going to have a negative 12. So meaning that when x is 1, your y is simply a negative 12. That's what we mean. So you also do the same. You take the other value when x is equal to negative 3. What will be the value of y by replacing into the original expression there? So how is that going to be? Well, it is going to be y is equal to, remember, x, negative 3 raised to the power 3 plus 3 negative 3 raised to the power 2 minus 6 minus 3 minus 10 there. So when negative 3 raised to the power 3 will give us a negative 27. This is negative 3 raised to the power 2, that is 9 times 3, that is a 27. Negative 6 times negative 3 will give me a positive 18 minus 10. When you add all that, that will give us 8. Remember, this and that will cancel. 18 minus 10 will give me just 8. Therefore, when x is a negative 3, my y is equal to 8. So meaning the points where the curve has a gradient of 3 are simply, the points are 1, negative 12, and the other point is negative 3, 8. So that's the way you can actually do that. Now remember, I told you that I'm going to teach you about a bit of composite function. So let me just give you a rule for composite function, because you're also going to be using it later on in your paper too. So the word composite, I can simply talk about composite, functions. So the word composite function can mean combined function. Remember, for example, when we told you to find the derivative of y is equal to 2x minus 3 raised to the power 2. This one was easy because you could easily expand this one and then you find the derivative. But suppose you have y is equal to maybe 3x minus 5, maybe let's say raised to the power 5. It, of course, you need to expand all the way, but it would be lengthy and even more tedious. You would actually waste a lot of time. So we can devise a simple way of trying to find the derivative of such expression by using what we call the composite function. So now, according to the composite function, what we can do, let me start with this one here. What we do, simply says, so according to the rule for composite function, before I look at it, to find dy over dx, you can use what we are calling as being, du over what we are calling as being du over dx multiplied by dy over du. So that's the formula that we are going to use. Now, how does this come about? Well, let me show you how you can do that. You get that expression y is equal to 2x minus 3 raised to the power 2. So what you're going to do, you let this term in the bracket be equal to u. So I'll simply say, let my u be equal to the term inside the expression 2x minus 3. So if this is representing u, then I can write, say, y is equal to u. In terms of u, because this whole thing is u raised to the power 2. So what we do there is very simple. So y is equal to u raised to the power 2. Let me just write it in that direction. So you have seen the expression inside is equal to u, and therefore I can write the whole thing by saying y is equal to u, because 2x minus 3 is now represented by u raised to the power 2. So what do? You differentiate these separately, then you come and just multiply. So it is here, it will be, what is outside it is u, so it is du over what is inside x. So du over dx is equal to, when we differentiate that, 2x, remember a number and a letter, you just have 2. A constant will give you a 0, so I'll just have a 2 there. What about this side? It will be dy over du. It will be 2 times 1, which will give me 2u. That power reduces by 1, so it will just be, u. So now once you get this and you get that, you get your du over dx, you can now find dy over dx by using that formula. It is dy over du times du over dx. It doesn't mean they cancel because you are differentiating. So what is the expression dy over du? It is simply 2u multiplied by du over dx. It is just a 2. So if you notice, this times that will give me a 4u. But I can substitute, since I know what my u is, it will be 4. What is my u? My u is representing 2x minus 3. So you can either do that, or you can expand this times that will give you 8x. 4 times that will give you a minus 12. That's what we mean. Well, let's use that other example again so that we try to show you how to treat composite function. So suppose they tell you find dy over dx, for y is equal to 3x minus 5 raised to the power 5. Of course, what you do is that, your u will be equal to the expression there, which is 3x minus 5. It simply means the whole expression can be written y is equal to u, because 3x minus 5 is now u, but raised to the power 5 there. So we differentiate individually, then we just come and multiply. That's the idea. So here it will be du over dx will be equal to, remember, a number and a letter, you just remain with that. That's a constant, it's a 0, you can ignore it. There, dy over du will be equal to, it is 5 times what is there, which is the 1, so it will be 5, then u, the power reduces by 1, so it will be 4. So now, therefore, to find dy over dx, it is the dy over du times du over dx. In essence, you think these are cancelling, but please, they don't cancel because you're finding the derivative. So what is dy over du? It is 5u raised to the power 4 times. That is a 3. So it is 3 times 5, which will give you a 15u to the power 4. You can now replace back your u. What is my u? My u is representing 3x minus 5, then this whole thing is going to be raised to the power what? Is going to be raised to the power 4. Let me just write that one. So that is our dy over dx using what we are calling as being composite function. So if you find it that way, you can use composite function because you cannot expand up to the 5th term. It's going to be lengthy, but you can use composite function to do that. Thank you so much. Watch out for my more videos as we look at integration. Continue with our calculus, but we look at how to integrate and hence other things like finding the equation of the normal and the tangent.